Okay, a complex fraction is a fraction within a fraction. And that would be considered not simplified. So I like to say that I have this big fraction. And within that big fraction, I have little fractions. And that's one of the things that a little fraction within a bigger fraction is a fraction within a fraction. Now, I'm going to count the number of terms I have. I've got 1, 2, 3, 4 terms. I'm going to look at those 4 terms. I've got a 4 over 1, and I make each one a fraction if it's not. 1 over x squared, and in the denominator I've got 2 over x minus 1 over x squared. And I'm looking at these denominators, a 1, an x squared, an x, and an x squared. And the lowest common denominator would be an x squared. So I'm going to multiply all of the numerator by x squared, and I'm going to multiply all of the denominator by x squared. So I'm going to multiply that denominator by that lowest common denominator. What did I say? I'm going to multiply each term in the fraction by that lowest common denominator. I'm not quite sure what I said there. I think I said denominator one too many times. So that lowest common denominator, the LCD, is an x squared, and that's what I'm multiplying the numerator and the denominator by, because x squared over x squared is 1. So I'm not going to change the value. I'm just going to change what this looks like. And you'll see. When I multiply x squared times 4, I'm going to get 4x squared. And when I multiply x squared times 1 over x squared, I'll come over here, x squared times 1 over x squared, the x squareds cancel out. So I'm going to have a minus 1. And then in the denominator, x squared, whoops, sorry about that. There we are. X squared times 2 over x squared times 2 over x. Well, the x squared over x is going to be an x in the numerator. So that's going to give me 2x. And then x squared times 1 over x squared is just 1. So I get minus 1. Now we're back to where we were before, and we're just ready to factor the numerator. That's going to be 2x plus 1 times 2x minus 1 over the denominator of 2x minus 1. I'm going to put that in parentheses. The 2x1 minus 1 cancels out with the 2x minus 1, and I have equals 2x plus 1. And that's my final answer. Okay, I'm going to erase this. And we're going to try another one, number 18. I've got a fraction within a fraction, so that's called a complex fraction. So I'm going to rewrite this so that every term, which there happens to be 4 of them, 1, 2, 3, 4, I'm going to make every term have a fraction. So x over 1 minus 1 over x squared all over 1 over x squared minus 1 over 1. And I'm going to show you just a little bit differently. I've got a denominator of 1, x squared, and 1. So the lowest common denominator would be x squared. I'm going to multiply. You saw me distribute the x squared. So the reason this works is because I'm multiplying by a factor of 1. And when I multiply the numerator by x squared, I have to multiply everything in the numerator by x squared. And when I multiply the denominator by x squared, I have to multiply everything in the denominator by x squared. Nothing's broken. I'm just waiting for the planes to kind of fly by. So if you're sitting there wondering, why it slowed down or stopped. If there was an error, it didn't. It's just the planes are flying by. So what I'm going to do here is, rather than say multiply by x squared over x squared, I'm just going to distribute, and I'm going to just show you what I do. I multiply each term by x squared. So I just do that. And it helps me see. I don't have to put arrows or anything like that. It makes it a little bit easier for me. So this first fraction, x squared times x, is x cubed, minus this second fraction, x squared over x squared, is just a 1. So these cancel out. And then x squared over x squared, that cancels out, and I have a 1 minus. And then 1 times x squared is just x squared. And we know that this factors. I've got the difference of cubes in the numerator, so that's going to be a small parenthesis and a bigger parenthesis. And then in the denominator, I'm going to have the difference of squares, so that's 2 small parentheses. So in the numerator, I'm going to have x minus 1, and then x squared plus x plus 1. So we talked about factoring the difference of cubes. So I factor that one. And then in the denominator, I'm going to have 1 minus x and 1 plus x. So we've got the difference of squares. Now this, I love this right here. This right here is almost 1. But because my 1 and my x are reversed, I'm going to have to factor out a negative. So this is the same thing as a negative 1. So my final answer, I'm going to make myself just a little room here. My final answer is going to have that negative 1 in the numerator, or an opposite of all of x squared plus x plus 1, all over 1 plus x, or x plus 1. This could be an answer. You could have this. You could show that negative 1. I'm okay with that too. If you wanted to, you could switch the x and the 1 to make it x plus 1 if you're more comfortable with that. But remember that x plus 1, 1 plus x, it's in parentheses. So the only thing it can cancel out with is a grouping of the same exact addends in the numerator. And that doesn't occur. So that is our final answer. Now we've got 3 more. I'm going to do this in another video. If you think that you've got enough to go on and you can try those, you could do that and then just watch the video to get the answers. So I'll have those answers in the next video.